tickle.
No tickle.
Tony, 27% of Americans report checking Facebook while in the bathroom. You would never do that, would you?
I'm Tony Kornheiser. I don't use the bathroom. I'm a kitchen sink man.
Tony.
Okay, so today we are looking at proving trig identities, PTI. And if I can find my marker, I can do some math problems for you. All right, so you have a few problems that you've already done with this. I'm going to go over two additional examples that are a little more challenging. One of them is problem 14 from the work. And you've got to do the odds, so I'm not making it any easier for you by doing an even problem. We have secant x over sine x minus sine x over cosine x equals cotangent x. Now, like with any proving situation, you want to generally work with the uglier side, okay? And this book kind of sets it up nicely for you. Pretty much every problem is the left side. Okay, the left side of the equation you want to work with. So we're going to ignore this. That's our end goal. We're going to get there, okay? So we've got to demonstrate that this stuff is really the same as cotangent x. All right, this difference is the same as cotangent x. So we've got to manipulate this and whittle it around and just narrow it down to just plain old cotangent. And it looks like a daunting task. It's not easy, but you'll see once you get this kind of problem, once you get from here to this, it's very gratifying. It feels good. You might hit a roadblock somewhere, you might need to start over, but always a good idea. You have sines and cosines in here, you have that pesky secant. So I would change that secant to start. All right. So if you make this, I will show you this, but you know, I'll show you in a second. Actually, all right. So this secant is like 1 over cosine. Okay. So we have 1 over cosine over sine. All right. So it's going to become 1 over cosine x sine x. Now I didn't show the step in the middle there, but what's really happening, if I can show you down here, it's like 1 over cosine x, that replaces the secant x, and it's over sine x. So it's like 1 over cosine x divided by sine x over 1, right? So instead of dividing by a fraction, we can just multiply 1 over cosine of x by the reciprocal, which is 1 over sine x. And we end up with this. All right? You don't need to show that intermediate step, okay? But if you have to, that's fine. Maybe do it on the side of your paper. 1 over cosine divided by sine, it's like sine over 1. So we end up with 1 over, 1 times 1 is 1, cosine times sine is cosine sine, minus sine over cosine. Now, this is much more manageable. We've got a rational expression we want to simplify. We need a common denominator. So I'm just going to multiply the right-hand fraction by a fancy version of 1, which is valid, right? You can't multiply both sides of the equation by a certain number because it's not an equation anymore. Okay, it's just one expression. But you can always multiply by a fancy version of 1 just to change the setup, right? To change the look of each expression. So this is going to be 1. We'll rewrite this left-hand fraction. Minus sine times sine is sine squared. Oh, you see what's going to happen? Over cosine x sine x. Now we have a common denominator, so we can just do the subtraction. 1 minus sine squared x over cosine x sine x. Now 1 minus sine squared, as you know, is just cosine squared. So we're going to replace that. Cosine squared x over cosine x sine x. Okay? And now you have cosine squared over cosine. Okay, so you can cancel out. There's a form of 1 inside here, right? Cosine x over cosine x is 1, but you're still left with 1 cosine x up there. Okay, so this simplifies to just plain old cosine x over sine x. All right, maybe you want to put equal signs in each step just to show me where your steps kind of begin. And if you had room underneath this, I hope you guys can see this, but it just says cosine x over sine x here. This is equivalent to cotangent x. So that means We have demonstrated what we needed to. Therefore, quod erat demonstratum, right? Latin for we did it. We show that this side equals this, right? Now, we'll go over one more example. I just want to see on here if you can see what I'm writing at the bottom, and you sort of can't. So that's what I've written down there, if that was bothering you, right? As per your suggestions, I'm going to lift this up again and move over instead of tilting the computer. Thank you for that, Adam Holtz. All right. Now we're going to do problem 18, I believe. That's what I wanted to do.